Let's use the chain rule to find a few more derivatives. In part D, we have f of x is equal to the cosine of x to the fourth plus 8x. As always, it's important to identify what's the interior function and the exterior function. For this one, it's pretty easy to identify that x to the fourth plus 8 to the x is going to be that inside function. And then after finding that value, you would plug it into the cosine, making the cosine the outside function. With those two identified, it's a lot easier to now use the chain rule in order to differentiate, starting on the outside and working our way inside. The derivative of cosine is going to be negative sine. Then we'll just keep that x to the fourth plus 8 to the x as our value, what we're going to take the sine of. So now that the cosine is done, we'll take the derivative of that interior function, which derivative of x to the fourth is 4x to the third. And the derivative of 8 to the x is 8 to the x with a natural log of 8 afterwards. There's really nothing else that we can do. And so this would be the simplified version of this derivative. In part E, g of x is equal to the cosine of x squared. And it's important to recognize that now that square is on the x and not on the cosine like is really common. With that x squared in parentheses, this is going to be our interior function, with cosine being our exterior function. Now we can jump into differentiating using the chain rule by working from the outside in. So the derivative of cosine is negative sine of that same x squared, and then we'll multiply that by the derivative of the inside, 2x. The only way really to clean this up is we would tend to take the 2x and bring it in front, so negative 2x sine of x squared. The only reason for that is so that you don't confuse yourself and think that you would find the product of x squared and 2x and then take the sine of that. So that's the simplified derivative for g of x. Last one is kind of a big one. H of x is equal to 4 over the log base 4 of x. Here's another example where it's probably a good idea to rewrite the function, making it easier to identify what's on the inside and the outside. In this case, since I have a fraction, I'm going to take the denominator and raise it to the negative 1 power. The denominator being log base 4 of x. Now I can see that my interior function is going to be that log base 4. Then I would take it to the negative 1 power and finally finish up with that 4. So 4 being the outside function. Now, when we use the chain rule, we're going to work from the outside in. So if I had 4x, the derivative of that would just be 4. Not times anything, it'd just be 4. So that derivative has been taken care of. Next we'll deal with the power, which is bring the power down times log base 4 of x and reduce the power by 1. So now it's at a negative 2. Finally, we have to take the derivative of what's on the inside, that log base 4 of x, which is going to look a lot like the derivative of natural log in that we'll do 1 over x, but we have to multiply it by 1 over the natural log of 4 as well. In order to try and clean this up a little bit, I do recognize that I have a fraction, so I'll probably mess with that. Just identifying what should be in the numerator, what should be in the denominator. With this 4 times negative 1, that would definitely be in the numerator. Log base 4 of x has a negative power, so I would bring that into the denominator, log base 4 of x squared, becoming a positive power. And then I have an x and a natural log of 4. Nothing else is going to cancel or anything, so that would be a simplified version of this derivative.